Welcome to Chemistry edition of Darling Fees channel. My name is X-COCO and I am excited to present to you solubility rules. In this lesson, I will teach you a simple trick using what I call X-COCO's pentagon style. So just a pentagon and we are good to go. Please do this for me. Kindly subscribe to see more of our presentation on this channel. I hope you are ready. Now let's go through the rules together before we look at the pentagon. The first one is saying that all sorts of group 1 metals, lithium, sodium, potassium, etc., they are soluble in water. We can also talk about ammonium salts. They are soluble in water except some transition metal compounds. Next, all nitrates salts are soluble in water. Also, all acetates are soluble in water. But we do have an exception. That is, it is insoluble when you have silver. Next, all sulfate salts are soluble in water except those of strontium, barium, and lead. The sulfate of calcium and silver, that is Ag+, are sparingly soluble. Please, we'll be using this, so just get them. Next, all chloride, bromide, and iodide salts are soluble in water except those of silver, mercury, and lead. Also, all sulfite, that is SO3 2-, and sulfide S2-, they are insoluble in water except those of group 1 metals. Now when we talk about group 1 metals, we are talking about lithium, sodium, potassium, etc. and Ca2+, Sr2+, Ba2+. We can also have ammonium ion. The next one, all silver salts are insoluble. We do have exceptions. That is when you have AgNO3 and AgClO4, AgC2H3O2 and Ag2SO4, they are moderately soluble. We understand these rules as we progress. Also, we have all hydroxides and oxides to be insoluble in water except those of group 1 metals and ammonium ion. Also, those of calcium, that is Ca2+, Sr2+, and Ba2+, are sparingly soluble. So in a way, we can say that they are insoluble. Now let's look at this simple pentagon. Now get your pen and let's draw this pentagon. So draw a nice pentagon as it is indicated here. I hope you are done. Now on the pentagon, draw a circle. So we are going to go anti-clockwise. So one here, we move to the second one, the third one, we have the fourth one. This side will give us the 5th point. Inside the pentagon, please draw another circle. Okay, I hope you are done. This is a simple pentagon that will help us to memorize all the rules that we talked about. I hope you are ready. Now let's see. With this pentagon, we have arrows indicated on the 2nd, 3rd, and the 5th one. What does it mean? It means that in my trick, the ones with the arrow indicates that we are going to start from them. That is when we make reference to the rules. The one here is without an arrow, meaning that we start from the one inside, then move to outside. Please, I hope you get that. Let me repeat that. With the trick, where we have the arrows, indicates that with the rules, we start with that. A typical example is what we have here. We said that all hydroxides and oxides are insoluble except then we added some ions. So that OH minus and O2 minus will come here. Now when we come to the first one, we also said that all sulfates are soluble, except then the ions, that is the exceptions, will come here. Please take note of this. Any ion inside the pentagon is soluble. Those outside, they are insoluble. So if I am outside and I'm insoluble, and I combine with someone who is inside here, who is soluble, automatically I become soluble. Once again, if I am outside, that is here, which indicates that I am insoluble, and I combine with someone who is inside, who is also soluble, automatically I become soluble. Now what about if I am inside? If you are inside, yes, you are soluble. When you combine with someone outside, because it is insoluble, automatically you become insoluble. Now how can we commit this into memory? As you have drawn your pentagon, let's move. So over here, we want to start with the pentagon. So these are the 5 sides that we talked about. 1, 2, 3, 4, 5. Then the middle circle is also here. So we start with the rule. Now over here, we say that all sulfates are soluble, except when they combine with these ions. Get that? Now let's come to this side. Because there is an arrow here, it indicates that all hydroxides and oxides, they are insoluble except when they meet with the ions here. Don't worry, I will give you a simple way of saying this. The next one here indicates that there is an arrow. So all SO3 2 minus, S2 minus are insoluble except when they combine with these ions. There is no arrow on this, so we can start from inside. That is from the rule. All chlorides, iodides, and bromides are soluble except when they combine with these ions. With the one here, we have an arrow on it, meaning that we are going to start from outside. That is what the rule states. So all phosphates, carbonates, chromates, silicates are insoluble except when they combine with these ions. So you may ask, what is the meaning of J1? J1 refers to group 1 metals. Take note of that. Now we are going to sing along so that we can easily fill the pentagon that you have drawn. Are you ready? So let's go. This is how I mention this. Pa, kas, ba, su. So we start from outside, then move to inside when you want to fill. Bear in mind that you should know the ions that we are talking about. Pa, kas, ba, su. So we have Pb2 plus, Ag plus, Ca2 plus, Sr2 plus, Ba2 plus. And that will give us pa, kas, ba, su. Now let me give you the whole thing. Then we pick them one by one. So we go. Pa, kas, ba, su. O, hu, kas, ba, j, n. S, u, s, kas, ba, j, n. Pa, si, pa, si. P, C, C, S, J, N. Let's take that again. So whenever you want to fill, just sing along. Pa, kas, ba, su. O, hu, kas, ba, J, N. S, U, S, kas, ba, J, N. Pa, si, pa, si. Then you move to the fifth one. P, PCCSGN. I hope you have that. Now inside here, that is the simplest. It says that all nitrates are soluble. We have the acetate here. They are all soluble except when they come to contact with Ag+. Now let's look at the actual diagram of the pentagon style. So this is what we are talking about. So anytime you are given a question, you can just recite what I just mentioned and fill that in the pentagon. So let's sing along. Pa, cas, ba, so. Bear in mind the ions which are supposed to be there. O, who, cas, ba, Gn. As we said, Gn stands for group 1 metals. SOS, cas, ba, Gn. Then we have Pa, C, that is lead, silver, and mercury. Pa, C. Then the last one, PCCS, Gn. I hope you get that. Now let's sing again. Pa, casba, so. O, who, casba, Gn. SOS, casba, Gn. Pa, C, PCCS, Gn. So if you are able to write this or draw this and fill in the ions, it really helps when it comes to determination of solubility for compounds. Now let's see how we can apply that using this question here. The question reads, name the precipitate formed when aqueous solutions of the following pairs of compounds are mixed. So in the solubility rules, it helps us to determine whether a compound is soluble or insoluble. Now let's pick them separately. Whenever you are given a question and they use the word N, it means that you have to write an equation for the two. That is AgNO3 plus MgCl2. But before that, let's see how we can easily determine whether what we have here is soluble or insoluble. So if you have your pentagon in front of you, it tells you that all nitrates are soluble, which indicates that AgNO3 here is soluble. Let's look at this one. MgCl2. Please keep that in your head. When we got to the fourth point, we said that all chlorides, iodides, and bromides are soluble, except when they come into contact with Pb2 plus, Ag plus, and mercury. But the question is, what we have here, is it part of the exceptions? No. Let's go back. This is what I'm talking about. So chlorine here, when it combines with those outside, that is these ions, it becomes insoluble. It is soluble here, but when it combines with any of the ions here, it becomes insoluble. And in the example we talked about, we don't have any Mg here. So automatically that compound also becomes soluble. I hope you understand that. Let's pick this one. Pb bracket open NO3 subscript 2. It says that all nitrates are soluble. So this one we don't have to even go back and check. Now let's look at what we have here. Na2CO3. Can you recall the fifth point? That is all carbonates are insoluble. So let me take you back. That is what we have here. This is where we have the arrow. So as I said, if there's the arrow indicated on it, it tells you that it is starting. So all carbonates are insoluble, except when they combine with group 1 metals and ammonium ion. But let's look at the combination. Is Na a group 1 metal? Yes, it is a group 1 metal, which indicates that carbonate here is insoluble, but when it combines with a group 1 metal, it becomes soluble. So that is how we use the solubility rules. Now let's look at the complete equation for the first one, second one, and the third one. Now if it is a mixture like this, we depend on the product to determine whether a precipitate will be formed or not. We don't depend on the reactant. So please take note of that. You react the two, write the products, then based on that, you determine whether it is soluble or insoluble. Now let's look at the combination. So in the first one, we had AgNO3 and MgCl2 coming together. Ag will combine with Cl, and that will give us AgCl as indicated here. Mg will also combine with NO3, but we all know that all nitrates here are soluble. So in this MgNO3, that is Mg to bracket NO3 subscript 2 will be soluble. So no PPT will be formed for this one. But in the case of AgCl, when you look at the rule, so the pentagon you have drawn, it states that all chlorides are soluble except when they meet with Pa. And you could see that with the Pa, Ag is also part. So that tells you that AgCl is insoluble. So PPT will be formed. Now let's look at the second one. We have Pb here. We have into bracket NO3 subscript 2 combining with sodium carbonate. This Pb will combine with CO3. Na will also combine with NO3. Now when Na combines with NO3, that will give us sodium nitrate. And with the rule, as I said, all nitrates are soluble with no exception. So this one is soluble. So no PPT will be formed for that. But let's look at Pb and CO3. In this case, Pb combines with this to give us PbCO3. Now let's go back to the rule. The rule says that all carbonates are insoluble except when they combine with group 1 metals and ammonium ion. Except group 1 metals and ammonium ion. By looking at what we have here, Pb is not part of the group 1 metals. Pb is a different thing. So it tells you that CO3 combined with Pb is automatically insoluble. So PPT will be formed. Now let's look at the last one. I wish you could try this, but let me help you. That is ZnSO4 and BaCl2 combining. Ba will combine with SO4. Zn also combine with Cl. Now let's look at Zn combining with Cl. That will give us ZnCl2. Is it going to be soluble or insoluble? Now let's look at Cl. The rule states that all chlorides, iodides, and bromides are soluble except when they meet with Pa. That is Pb2 plus, Ag plus, and Ag2 plus. So looking at this, Zn is not part of the exceptions. So automatically, ZnCl2 becomes soluble. So in our case here, we are not going to see a PPT form. But when we pick Ba and SO4, now let's go back to the rule. The rule says that is, if you could remember, we have PCCS. We also have all sulfates are soluble. This is part of the first one. It is not part of the PCCS. So we can say that all sulfates are soluble except when they come into contact with Pacasba. Do you remember that? Yes, Pacasba. And from Pacasba, we all know that this one is the last one, Ba. So all sulfates are soluble except when they combine with barium, which indicates that inside the pentagon, sulfate here is soluble, but when it meets the one outside,